Missing hyphen in NASA's Mariner 1. On July 22, 1962, NASA launched the Mariner 1 spacecraft toward Venus as part of America's first interplanetary mission. The rocket lifted off from Cape Canaveral carrying sophisticated instruments designed to study Venus's atmosphere and surface temperature. 4 minutes and 53 seconds into flight, the range safety officer pressed the destruct button. $80 million worth of cutting-edge technology exploded into the Atlantic Ocean. The destruction happened because of a single missing punctuation mark in the rocket's guidance software. The original mathematical formula was supposed to read r.bar_n, where the hyphen indicated an average velocity over time. A programmer accidentally omitted the hyphen, creating r.bar_n, which the computer interpreted as an instantaneous velocity rather than an average. This seemingly tiny change caused the guidance system to send erratic steering commands to the rocket's engines. As Mariner 1 climbed toward space, its guidance computer began receiving conflicting velocity data. The missing hyphen made the system think the rocket was moving much faster than it actually was, causing it to overcorrect its trajectory repeatedly. The spacecraft started veering dramatically off course, swinging back and forth in increasingly wild oscillations. Ground controllers watched helplessly as their expensive probe began heading toward shipping lanes and populated areas instead of Venus. Overloaded ferry due to a birthday cake. On December 20th, 1987, the MV Doña Paz ferry departed from Leyte Island in the Philippines, carrying passengers to Manila for Christmas celebrations. The ship was designed to hold 1,518 passengers, but maritime investigators later estimated over 4,000 people were actually aboard. The overloading happened because of a last-minute birthday celebration that convinced hundreds of additional passengers to board at the final port stop. A wealthy passenger's family had organized a large birthday party on the upper deck, complete with a massive multi-tiered cake and live entertainment. Word spread quickly through the port town that free food and festivities were available to anyone who could squeeze onto the ferry. Families who hadn't planned to travel suddenly bought tickets or simply boarded without them, drawn by the promise of free celebration food. The ferry's crew, eager to accommodate the party and collect extra fare money, allowed far more passengers than safety regulations permitted. At 10:30 p.m., the overloaded Doña Paz collided with the oil tanker MT Vector in the Tablas Strait. The ferry's excess weight made it unstable and slow to maneuver, preventing the captain from avoiding the collision. Both ships burst into flames immediately, turning the surrounding water into a sea of burning oil. The overloading meant there weren't enough life jackets or lifeboats for the actual number of passengers aboard. Only 24 survivors were ever found. Halifax explosion, 1917. On December 6, 1917, the French cargo ship Mont Blanc entered Halifax harbor carrying 2,653 tons of explosives destined for the battlefields of World War I. The ship's manifest included picric acid, benzol, gun cotton, and TNT, enough explosive power to level a small city. Captain Aimé Le Medec followed standard wartime protocols, flying the required red flag to signal dangerous cargo aboard. The Norwegian vessel Emo was leaving Halifax that same morning, bound for New York to collect relief supplies for Belgium. Due to harbor congestion from wartime shipping traffic, the Emo had been delayed overnight and was running behind schedule. Captain Håkon From was eager to make up lost time and reach the harbor mouth before other vessels blocked his path. Both ships approached the harbor's narrow channel, where vessels were supposed to pass port to port, left side to left side. The Mont Blanc moved to starboard as required, but the Emo, rushing to exit the harbor, had drifted too far to port and was now on a collision course. The captains exchanged whistle signals, each thinking the other would yield right of way according to maritime rules. In the final moments, both ships reversed their engines and turned hard to avoid collision, but their evasive maneuvers actually steered them directly into each other. At 8:45 a.m., the Emo's bow struck the Mont Blanc near the cargo hold containing benzol and picric acid. The collision sparked fires that spread rapidly through the explosive materials. The Mont Blanc's crew immediately abandoned ship, rowing frantically toward shore while shouting warnings in French that few Halifax residents understood. Curious onlookers gathered at windows and on rooftops to watch the burning ship, unaware they were staring at the largest man-made explosion in history before the atomic bomb. At 9:04 a.m., the Mont Blanc detonated with the force of 2.9 kilotons of TNT, instantly killing 2,000 people and injuring 9,000 more. Boston molasses flood, 1919. On January 15, 1919, a massive steel tank containing 2.3 million gallons of molasses burst open in Boston's North End, unleashing a deadly wave of sticky syrup that moved at 35 miles per hour through the crowded industrial neighborhood. The Purity Distilling Company had built the 50-foot tall tank in 1915 to store molasses used used for producing ethyl alcohol, which was in high demand for manufacturing explosives during World War I. The tank was a disaster waiting to happen from the moment of its construction. The company had hired Arthur Gell, who lacked proper engineering credentials, to design the massive steel structure. Gell used steel plates that were too thin for the enormous pressure they would need to contain, only 5/16 of an inch thick instead of the recommended half-inch thickness. The rivets holding the plates together were also substandard and improperly installed. Warning signs appeared almost immediately after the tank was filled. Local residents complained about groaning and creaking sounds coming from the structure, especially during warm weather when the molasses expanded. The tank leaked so badly that children in the neighborhood would collect the dripping molasses in cups. Company employees regularly painted the tank brown to hide the constant seepage, dismissing safety concerns as minor maintenance issues. The temperature had risen unusually high for January, reaching 43 degrees Fahrenheit after days of bitter cold. This sudden warming caused the molasses to expand rapidly, creating enormous pressure against the already weakened steel walls. At 12:30 p.m., during the lunch rush, when the streets were crowded with workers, the tank's north wall completely failed. The explosion sounded like machine gun fire as rivets shot through the air like bullets. A 15-foot-high wave of molasses roared through the narrow streets, crushing buildings, overturning vehicles, and trapping people in the thick, sticky syrup. The molasses was not the slow-moving substance people imagine. At 2.5 times the density of water and moving at highway speeds, it struck with the force of wet concrete. 21 people died and 150 were injured in what became known as the Great Molasses Flood. ValueJet Flight 592. On May 11, 1996, ValueJet Flight 592 took off from Miami International Airport, bound for Atlanta, with 110 people aboard. In the cargo hold, improperly labeled boxes contained old oxygen generators that SaberTech maintenance workers had removed from other aircraft. The workers were supposed to install safety caps on the generators to prevent accidental activation, but they skipped this crucial step and simply tossed the devices into cardboard boxes marked empty. Oxygen generators are emergency equipment designed to provide breathable air if a plane loses cabin pressure. When activated, they create oxygen through a chemical reaction that produces intense heat, over 500 degrees Fahrenheit. The generators are essentially controlled fires that burn sodium chlorate and iron powder to produce life-saving oxygen for passengers during emergencies. SaberTech had been hired to perform routine maintenance on ValueJet aircraft, which included replacing expired oxygen generators. The old generators were classified as hazardous materials that required special handling, documentation, and disposal procedures. Instead of following these protocols, workers simply removed the generators and threw them in boxes without the required safety caps that would prevent accidental triggering. The maintenance crew filled out shipping papers declaring the boxes contained empty oxygen generators, when they actually contained live, dangerous devices. Federal regulations strictly prohibited transporting unexpended oxygen generators on passenger aircraft because of their fire risk, but the mislabeling circumvented all safety checks. The boxes were loaded into the forward cargo hold, directly beneath the passenger cabin. 11 minutes after takeoff, at 24,000 feet, the oxygen generators activated inside their cardboard boxes. The chemical reaction created a fire that reached temperatures hot enough to melt aluminum and burn through the aircraft's control cables. Smoke filled the passenger cabin as the pilots lost control of critical flight systems. The DC-9 plummeted into the Florida Everglades, killing everyone aboard in a crash caused by $5 worth of missing safety caps. The London Beer Flood, 1814. On October 17, 1814, a massive vat containing 135,000 gallons of beer burst at the Mew & Company Brewery in London's St. Giles Parish. The rupture triggered a catastrophic chain reaction that sent over 388,000 gallons of porter beer flooding through the densely packed slums of one of London's poorest neighborhoods. 8 people drowned in beer, and the disaster destroyed entire blocks of ramshackle housing where families lived in cramped basement-level rooms. The Mew Brewery specialized in porter, a dark beer that required aging in enormous wooden vats called tuns. These massive containers stood 22 feet high and were bound together with thick iron hoops to contain the pressure from fermenting beer. The largest vat, known as the Great Tun, held more beer than most breweries produced in an entire year. Brewery workers had noticed the iron hoops were showing signs of stress, but management dismissed these concerns as normal wear from the wood's natural expansion and contraction. At 5:30 p.m., during the evening shift change, the Great Tun's iron hoops snapped with a sound like cannon fire. The sudden release of pressure caused the massive wooden walls to explode outward, sending a tsunami of beer crashing into adjacent vats. The domino effect destroyed 7 more giant containers within minutes, creating a beer flood that burst through the brewery's brick walls and poured into the surrounding streets at tremendous speed. The neighborhood of St. Giles was a maze of narrow alleys lined with decrepit tenements where entire families lived in single basement rooms. When the beer flood hit, it filled these below-ground dwellings faster than residents could could escape. The thick, yeasty liquid was difficult to swim through and impossible to see through, causing people to become disoriented and drown in their own homes. One entire house collapsed under the weight of the beer, crushing a mother and daughter who were having tea in their front room. The flood covered an area of several city blocks and took hours to drain away, leaving behind a sticky, fermenting mess that attracted thousands of curious onlookers. The disaster bankrupted the Mew Brewery, but a court ruled the incident an act of God, meaning no one could be held legally responsible for the deaths and destruction caused by exploding beer. Radiation deaths at Goiania, Brazil. On September 13, 1987, two scrap metal collectors in Goiania, Brazil, broke into an abandoned medical clinic to steal valuable materials they could sell. Roberto dos Santos Alves and Wagner Mota Pereira found what appeared to be a heavy, well-built machine and decided it must contain precious metals. They spent hours dismantling a teletherapy unit, a radiation therapy machine used to treat cancer patients, completely unaware they were handling one of the most dangerous radioactive sources in medical use. The machine contained a cesium-137 capsule, roughly the size of a large coin, sealed inside a protective lead housing. Cesium-137 is an extremely potent radioactive isotope that emits gamma rays powerful enough to penetrate human tissue and cause severe radiation poisoning. The capsule had been abandoned when the clinic moved to a new location, leaving behind equipment that should have been properly disposed of by nuclear safety authorities. After hauling the heavy device to Roberto's home, the two men used a screwdriver and hammer to break open the lead shielding, exposing the cesium source inside. They were fascinated by the capsule's contents, a glowing blue powder that seemed magical in the darkness of Roberto's backyard shed. Neither man had any idea they were looking at one of the most lethal substances on Earth, with enough radioactive material to contaminate an entire city. Roberto became ill within hours, but didn't connect his nausea and fatigue to the glowing powder. Instead of seeking medical help, he sold the scrap metal, including the ruptured cesium capsule, to a local junkyard owner named Dever Alves Ferreira. Dever was equally enchanted by the mysterious blue glow and brought the capsule into his home, where he invited friends and family members to admire the beautiful, luminescent substance that none of them could identify. Over the following weeks, people began taking small amounts of the glowing powder to show their friends and relatives. Children rubbed it on their skin like body paint, fascinated by how it made them glow in the dark. Adults mixed it with food to create glowing snacks for parties. The cesium contamination spread throughout the city as people unknowingly carried radioactive particles on their clothes, in their hair, and under their fingernails. By the time authorities identified the source of a mysterious illness affecting hundreds of people, 4 individuals had died from acute radiation poisoning, and an entire neighborhood had to be demolished and buried as radioactive waste. Train conductor who forgot the brakes. On July 6, 2013, a runaway freight train carrying 72 tank cars of crude oil derailed in the center of Lac-Mégantic, Quebec, killing 47 people and destroying half the town's downtown core. The disaster began when locomotive engineer Tom Harding parked his train on a steep grade outside town and made a single fatal error. He failed to set enough handbrakes to secure 10,000 tons of rolling stock on a 1.2% downhill slope. The Montreal, Maine and Atlantic Railway train had stopped in Nantes, about 7 miles from Lac-Mégantic, after the lead locomotive began smoking due to an engine problem. Harding shut down the smoking locomotive but left 4 others running to maintain air pressure in the train's pneumatic brake system. He applied handbrakes to several cars, but company policy required securing at least 9 cars on such a grade. Harding only set 7. After parking the train, Harding called his dispatcher to report the locomotive problem and headed to a hotel for his mandatory rest period. What he didn't realize was that shutting down the smoking locomotive had eliminated the source of compressed air that kept the automatic air brakes engaged. The train was now held in place only by the insufficient number of handbrakes he had applied and the air pressure remaining in the brake lines. Later that evening, local firefighters arrived to extinguish a small fire in the smoking locomotive. Following standard procedure, they shut down all remaining locomotives to eliminate the fire risk. This action cut off the air compressor that had been maintaining brake pressure throughout the train. As air slowly leaked from the brake system over several hours, the enormous weight of 72 oil-filled tank cars began to overcome the 7 handbrakes. At 1:14 a.m., the unmanned train started rolling downhill toward Lac-Mégantic, gathering speed as it descended the 7-mile grade. By the time it reached the town center, the runaway train was traveling at 65 miles per hour, more than twice the speed limit for that section of track. The train derailed at a curve near the Musée Café, where dozens of people were enjoying Friday night festivities. The tank cars exploded in a fireball that consumed 30 buildings and created a crater 150 feet wide, all because one man forgot to set 2 additional handbrakes. Metric conversion error. On December 11, 1998, NASA's Mars Climate Orbiter began its final approach to the Red Planet after a 9-month journey through space. The $327 million spacecraft was designed to study Martian weather patterns and serve as a communications relay for future Mars missions. As the orbiter fired its engines to enter Mars's orbit, ground controllers expected to lose radio contact temporarily while the spacecraft passed behind the planet, a normal part of orbital insertion. The silence stretched far longer than expected. When the scheduled communication window arrived, no signal came from the orbiter. NASA engineers realized with growing horror that their sophisticated spacecraft had likely burned up in Mars's atmosphere or crashed into the planet's surface. The Mars Climate Orbiter had become the most expensive navigation error in history. The disaster occurred because two teams of engineers were using different measurement systems without realizing it. Lockheed Martin, the contractor building the spacecraft, programmed their navigation software to calculate thruster force in pounds of force, the imperial system used throughout American aerospace manufacturing. Meanwhile, NASA's Jet Propulsion Laboratory was running trajectory calculations, expecting those same numbers to be in newtons, the metric system unit that NASA had officially adopted for all Mars missions. For 9 months, every course correction and navigational adjustment was off by a factor of 4.45, the conversion ratio between pounds of force and newtons. Each time the spacecraft fired its thrusters to adjust its trajectory, the Lockheed Martin software was delivering 4.45 times more force than NASA's computers expected. Instead of making small, precise adjustments, the orbiter was lurching through space with massive overcorrections that gradually pushed it toward a catastrophic trajectory. The error compounded over millions of miles of space travel. By the time Mars Climate Orbiter reached the Red Planet, it was approaching at an altitude of just 35 miles above the surface, instead of the planned 140 miles. At that low altitude, the spacecraft encountered much denser atmospheric resistance than its heat shield could handle. The orbiter either burned up like a meteor or crashed into Mars, destroyed by a measurement mix-up that could have been prevented with a simple unit conversion check.